Hello my lovelies, it's Susanna, and today I want to show you how to solve this problem that was part of a 10th grade final exam from 1964. 3 circles with diameters of 60 millimeters, 100 millimeters, and 40 millimeters touch each other externally. If you connect the centers of the 3 circles, a triangle is formed. Calculate the interior angles of this triangle. So we are given 3 circles. We are also given the diameters of each of these circles. So maybe we start with these diameters. The largest circle has a diameter of 100. I'm not a fan of using the diameter in general, so I want to use the radius of this circle. It's half of the diameter, so we have a radius of 50 here. The smallest circle has a radius of 20 then, so half of the diameter. So we have a radius of 20 here. And the last circle, half of this is 30, so we have a radius of 30 here. Then they tell us if you connect the centers of the 3 circles, a triangle is formed. So let's connect the centers here, here, and here, and then we get this triangle, and we have to find the interior angles of this triangle. So if I call this angle here alpha, this one beta, and this last one gamma, then we have to find these 3 angles. Okay, so what do we know about our triangle? If we take a look at this side here, for example, then this consists of this part here in this large circle and this part here in the small circle. And this first part here, this is just the radius of my large circle. From the center to the edge of my circle, this is the radius, so it is a length of 50 here. And the same thing for this left part. This is the radius of my small circle, so it is of length 20. So the entire side is of length 20 plus 50, so it has a length of 70 in total. And the same thing with the other sides. We have 50 here, 30 here, so in total we have 80 for this side. And here we have 20 plus 30, which gives us 50 for this last side. So my triangle looks like this now. And we're still interested in the angles. The problem just is this is not a right triangle, or we don't know if it's a right triangle. So we cannot just use sine, cosine, or tangent because we don't know if it's a right triangle or not. But there's also the law of sines and the law of cosines that you can use in any triangle. The question just is, which of these laws can we use here now? The law of cosines, for example, uses all 3 sides of the triangle and one of the angles. You can choose any angle, whichever you want to find. We want to find all of them, so maybe let's just start with alpha for now. And because we are given the lengths of all of the sides, we can find alpha then now with the law of cosines. So, because we picked this angle here, we will need the side that lies across this angle. So, because this is alpha, then the side is my A. Across beta, I have B here, and across gamma, I have C then. And the law of cosines looks a little bit complicated, but it's the following. Because we've picked this angle, we have to start with the side that lies across this angle. So we have to start with A. We have to take the side A and square it. Then we get the other side squared, so B squared, plus the other side squared, so c squared. Looks familiar for now, the Pythagorean theorem, but we're not done yet. Now we have to subtract something. It is 2 times this side, so b times this side, c, and then times, because it's the law of cosines, we have cosine of the angle we've chosen, so of alpha. So every time you have alpha in your cosine here, you will have a on the other side, so the things that lie across each other here. Okay, let's insert everything. A is 70, so we have 70 squared equals b is 50. It's 50 squared plus c is 80 squared minus 2 times b is 50 times c is 80 times the cosine of my angle alpha that I want to find. And this is one equation. We have only alpha as an unknown in here, so we can solve this equation for alpha now. Let's do this on this side here. Let's calculate a little bit. You were allowed to use your calculator in this exam, so 70 squared, either you do it in your head or just type it in and you get 4,900. On the other side, we have a plus here, a minus here, but then we have multiplications here. So we have to start with the multiplications. 2 times 50 times 80 equals 8,000 here then. And then we can add these two here. If we just type it in, we get a result of 8,900. Okay, because of the multiplication here, these two belong together. We cannot subtract these two numbers. But we have alpha here. We want to solve for alpha, so let's get rid of the 8,900 here and put it to the other side by subtracting it on both sides of the equation. If we subtract this, we get negative 4,000. This here cancels out, and then we have negative 8,000 times the cosine of alpha. To solve for alpha, we have to get rid of the negative 8,000 now, so we have to divide both sides of the equation by negative 8,000 here and here as well. If we calculate this, we get 1/2 on this side. This cancels out, and only the cosine of alpha is left. Now, to solve for alpha, either you know that cosine of 60 degrees is equal to 1/2, or if you don't know this fact, it's not a problem, you can also use your calculator to find alpha. We just have to get rid of the cosine here. This will disappear if we apply the arc cosine on both sides of this equation. So we're going to apply the inverse function of the cosine, which is cosine to the power of -1. Let's apply this on both sides. So we have cosine to the power of -1 of the left side of the 1/2. And on the other side, if we apply this, the cosine here will disappear and only alpha is left. Now you type this thing here into your calculator and get a result for alpha of 60 degrees. We found our first angle. There are 2 more to go. So how can we find beta next? We could use the law of cosines again to find beta because we still have the lengths of all of the 3 sides. So we could apply the law of cosines now for this angle here. Or because we've just found one other angle, we could also use the simpler law of sines now to find beta. So we need an angle for this law in our triangle, and the side that lies across this angle. Both things are given, and these two form a group. And then, because we're interested in this angle here, but then for the law of sines, we would need the side that lies across this angle, but we're given the length of this side, so this looks really good for the law of sines. So we've just created two groups, this green one and this orange one. And the law of sines then says the following. Take the sine of one of your angles. You can choose either of them. We will need the other one anyway later, so we just pick beta for now. Then divide this by the side that lies across this angle. So we divide it by b by the 50. We can insert the 50 already. And then this is the same as taking the sine of the other angle. So now we do the same with the green group with a 60 degrees in here. And we divide it by the side that lies across this angle, so by a or by 70 in this case. And now we only have to solve this equation for beta. Let's get rid of the 50 here first by multiplying both sides of the equation by 50 so that this cancels out here and only the sine of beta is left on the left side. On the right side, well, yeah, there we have this beautiful expression. I don't want to type it into the calculator yet because I want to have these exact values, but these are just numbers, so don't be intimidated by this. You can just use your calculator later for this. We focus on our beta. We have to get rid of the sine here now, so we can use the arc sine on both sides. So the inverse sine, which is sine to the power of -1 on both sides. If we apply this here, the sine will disappear and only beta is left. But we also have to apply it on the right side. So we have sine to the power of -1 of this beautiful expression. So let's write it down once more. But the good thing is that we can just use our calculator now to find beta. You just type all of this into your calculator and get a result of 38.2 degrees for this angle here. Now we found two angles, just one is missing. How can we find gamma now? Because we already have two angles in our triangle, we can easily find the third angle now, because all three angles together in a triangle always have to be equal to 180 degrees. So to find gamma, I can just take the 180 degrees and subtract my two angles, the 60 degrees and the 38.2 degrees, and then I find my gamma, which is 81.8 degrees. And now I found all three angles and solved this problem. If you liked my video, please give it a thumbs up. It helps me a lot. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!